We're going to take notes on mass versus weight. You'll take notes in your binder, but you're not going to take notes on every single word that's on the slideshow, just the things that I've underlined for you, just the important stuff. So let's start with mass. Mass is a measure of the amount of matter in an object. This is a definition, so we do want to make sure we copy this down pretty exactly. Measure of the amount of matter in an object. Remember, this is the amount of particles or the amount of stuff in an object. The next bullet, mass is always constant for an object no matter where the object is in the universe. A lot of words we don't need. First of all, not everyone knows what the word constant means, so let's change constant to the same. Always the same, no matter where in the universe. So whether I go to California or Australia or the moon or Jupiter, my mass is always going to be the same, no matter where I go. It's measured using a balance. We've already learned this. We've been using balances in class, like this one, an electronic balance. The other picture is of a triple beam balance. That's what I had to use to learn how to measure mass. And we've already learned that mass we measure in grams. So again, all you should have are bullets with just the underlined information. You might want to pause here if you haven't finished before we move on to weight. Weight is the measure of the gravitational force on an object. Again, this is a definition, so we want to keep it pretty exact. This is a measurement of how much gravity is pulling down on an object. Weight varies depending on where the object is in relation to the Earth or any large body in the universe. Lots of stuff, don't know what all those words mean, so let's change some of them up. Varies depending on, you could change varies to changes. Weight changes depending on location. Now, if I go to California or Australia, my weight's not going to change because I'm still on Earth, and Earth has the same amount of gravity. But if I go to the moon or I go to Jupiter, that's when my weight changes. The moon has less gravity, so there's less of a force pulling down on me, so my weight's going to be less. Jupiter, on the other hand, has a lot more gravity. That gravitational force is a lot larger, so my weight would be larger on Jupiter. We measure weight using a spring scale, like we use in our lab. And the spring scale really shows the gravity's pull because it gets pulled downwards as you use it. And our unit is Newton. In the metric system, we don't use pounds and we don't use ounces, we use newtons. Now, weight depends on mass. We talked about this in our lab. The more mass something has, the more weight it's going to have, because there's more particles for gravity to pull on. And if it can pull down on more particles, then the measure of that pull will be larger. Larger the mass, the larger the weight.